Okay, everybody, I think we're ready to go for the afternoon portion of the day. Thank you for coming in, following on from the morning session for the second part of Translate the Intangible, which is a conference that's been put together by PhD students here at the AA to try and ground a discussion over the course of the day on the question of what it means to do advanced design research in a setting like this and at a time like this in architectural culture where questions of research and design are unfolding in many compelling and innovative ways, and most particularly around new design platforms and not just the practices but also the question of discourses and the culture that can surround such realities today. This afternoon session, Sessions 2 and 3 in the day's program, for those of you that don't have it, there are copies out in the hallway, bring together some incredibly accomplished practitioners alongside students in the PhD by Design program here at the A to discuss this topic of design and research. So thanks first for all of you for coming in for the session, our visitors for having come from various places around the world, a great effort to share some of their latest work and thinking on the topic, and for the discussions that will be held during the day around the materials that are being presented. I wanted to make three very brief points by way of introduction to the session this afternoon about what we've been thinking about here at the school in relation to the topic of advanced design cultures. I think the first one would be, and it's a topic that's been in discussion here in many places for many years, the question of what might constitute a research-based culture around design itself. So the question of design as research, which has already come up in various ways and will continue on over the course of the afternoon. I was asked at a fairly bureaucratic type setting last week to explain to people who came in from the outside what the A might possibly mean by the idea of research at a setting like this, in that we are most notably not a research university or resemble anything like the kind of institutions that pursue activities that today are called research. And the point I made to the group last week was that I think one reason people have thought about the experimental work at a school like this as a form of research over the decades is a result of the emphasis this place places on exactly this kind of an event, i.e. on the unfolding of work amongst audiences and the communication of results and ideas as they're developed in such a way that that communication itself shifts the production towards a model of research that I think many people would recognize as a key feature of everything from the research and development commerce today that drives corporations to the kind of research activities we think of in other fields, and certainly in fields far away from architecture. The AA, alongside many institutions and many of the kind of practices that are involved in the presentations today, are really committed to this idea that work must take place amongst other minds. And the positioning and the articulating of ideas and projects in relation to the work of either our peers or historical precedent or parallel fields of investigation is, I think, one of the tangible features of a generational shift that many of us have seen in architecture in recent years. A second point I'd want to make, and this probably goes to the form of today's presentations, in something that we were interested in thinking through, is what it means to stage a career today in a culture of architecture that thinks of itself increasingly as experimental and research-oriented. I think the staging of a career today and the articulating of how one is operating at any one moment in what will become a much larger and longer project is certainly a salient feature, you could say, of the individuals that have joined us this afternoon from great distance. I think in various ways what you're seeing in the work that our invited guests are presenting today is the work of people who haven't just got projects and are working on them, but have a remarkable capacity to explain and articulate the basis for the work that's forming the career that they're pursuing in various ways. I think that articulation of a career, of a longer-term research project, of architecture and architectural knowledge being something other than the episodic accident of moving from one thing to another, but the structuring of the relationship, or even the imagining of the relationship between those projects, is, I think, one of the key themes that we've been certainly thinking about within the program of PhD by Design, but also the question of design and research today. And the third and final point I wanted to make really just cuts more to to the title of today's session and this question of what it means to document the intangible in architectural work. And I think that was the title that our conveners gave to the session today. And by translating the intangible, I think what they were trying to draw attention to was the question of how one possibly documents the increasingly dynamic, if not animate, multi-mediated production of information and results that are a part of the design systems that many of these practices in presentation today are deeply embedded in and committed to investigating. I think undoubtedly the exponential amplification of media around everything that takes place today within the electronic design studio and the complexities that introduces to how one does or doesn't link design, thinking, and sensibilities to forms of manufacturing, production, and output. All of that raises incredibly compelling questions about what it means to document, give evidence to, and structure the arguments around what design thinking might be today. I think many of us are aware of that in different forms. Maybe what's most interesting to remember in that problem is that while the media and the technologies verge towards the new, let's say, in our confrontation with them, that demand of articulating and translating the intangible, you could say, lies at the very core of a disciplinary definition of architecture. Forever, the mental concepts that we think of as architectural theory or architectural thinking have posed immense challenges to architects in terms of their translation and communication. And one way to write the history of the discipline is to write the history of brilliant minds finding a way to communicate ideas about incredibly arcane theories and ideas. And I think there are lessons probably to learn in that deep disciplinary history of architecture, but I think over and over again what one sees in the kind of work being presented in this session this afternoon is that that challenge has entered an entirely new kind of dimension, space, and reality today. And I think how a generation, or already I think it's fair to say new younger generations, there's more than one out there right now, confront that reality and use it to reform or reshape architectural culture will be an incredibly interesting project in coming years. Last point in this little introduction is just to say thanks most certainly to Ali, Ilif, and Marat for coming to me a few months ago with the suggestion to put this symposium together on behalf of the other PhD by design and PhD students here at the AA. This is absolutely a student-led initiative in a school right now in which students seem to be doing all kinds of things on their own, in which people like me are simply trying to keep track of what's going on. Alongside the various student newspapers, magazines, there's a student newspaper, a student radio station, I'm sure there's a TV station or two out there. Alongside this kind of incredible explosion of communication and the re-embedding of that relaying of what's happening within studios to larger audience lies the more considered kind of example that you get in this symposium today. So thanks again to all the students for putting that together. It's just an opening gambit in a project that's been unfolding over the last couple of years here as the AA was able to institutionally validate and establish what we're now calling a PhD by design program. I think architectural culture has entered an interesting early 21st century moment where advanced design experiments and projects are demanding increasingly the setting up of platforms like this course alongside many others to allow individuals many years of yet further research and design into work that'll lead to careers in new and unexpected ways. And I think we can, more than anything, say that we just hope to use today's session as a chance to push that conversation a bit further. And on that front, thank you everybody for coming in today. And I'll turn it over now to the students.
Good afternoon, all. Welcome to the symposium. I hope you are enjoying, and thank you, Brett, for making possible organizing this event. With a session 2 that is going to be moderated by Arturo and myself, we don't need to really do a further introduction to our known guests. So we have Axel Kilian, that's the assistant professor of School of Architecture at Princeton University, and Branko Kolarevic, that is the associated dean at the University of Calgary, professor and also of the chair in integrated design. So today I'm going to talk about a part of my research that I'm framing down into a small part, or actually I'm looking at. So I have more questions than answers, and I'm going to share them with you. So very quickly, I'm going to tell you that one of the problems I've been facing, I'm trying to redefine the concept and the function of what was before calling the face of the building. So I'm redefining it as a transitional space in between the inside and outside, also answering a need that the users always show when they extend the private space towards the outside. This transitional space is going to be the threshold between the internal and the external environments. And I'm trying to find answers for this question, looking at material behavior combined with design and fabrication techniques to achieve the desired performance. So some examples that you have been looked at, that somehow they coincide in different terms, maybe sometimes it's the material, sometimes it's a function or the scale, have been putting together, but they always stay in the scale of pavilion or the screen of the facade. So this research is trying to go beyond that and trying to extend the scale and the principles and function of these spaces. So in these examples, what you can see that we go beyond what was traditional, the face of the building, and then evolves to the double layer facade, and now I'm extending and unfolding these two layers in a space that can be habitable and suffers alteration through the time of the year or the way that the material is putting together. So what is the reason that research or the work that you can see doesn't go further this screen or doesn't go further the pavilion scale? Is that a material reason? Is that a combination between material and design? Why you don't take what was before maybe the constraint, the material constraint that was constraining design, why you don't take it as a strength? So if you work with the material and you manipulate the material, maybe you can achieve certain qualities that before were not explored. Especially in my research, I'm looking at wood, and we think that wood have been used for a long time, but maybe we can still work on that in an innovative version of it, and through digital fabrication together with design, maybe you can achieve different performance. So one of the issues was looking at nature, since there are many examples and many models that a monomaterial layer can perform differently. And in this case, we have the Bankia nut that performs differently according with the region that you are talking. So they have soft materials that allow the expansivity, and they also have harder materials that just stay the structures together. So how can you have this monomaterial layer that performs as a multi-material layers as we see in architecture? So looking at from the surface to the inside, we have layering of materials, but let's put it together another way. We have the same material, but arranged in a different way. So we go back again to the transitional space, and if you look at the models where, for instance, we extract mathematical relationships, and then we abstract and incorporate as an input as in the design. So we can just play from the what was mathematical before can be translated in material. And through the design and also the loop between design and fabrication, we can just look at the face or the outside surface of this transitional space as we look at before at that biological model that was performing different porosities with the same material. This was the reason that we were looking at the biological model. So here we can see through the information, the mathematical information that was abstracted from the models, we can start playing different kind of geometries and also different kind of porosities. So relating the environmental conditions and also social conditions such view or privacy, we can start playing with different porosities that will be translated through the design through fabrication. And this process is a loop process that goes from the design, understanding the problems, go to what was the materiality, and then go back after the physical experiments to inform again design. So the next steps on this work would be still working on the calibration between the digital and physical, such material properties, the geometry, or even the cutting patterns that relate to the performance you want to achieve, and then, of course, measure and evaluate all the produced objects. Thank you.
Hello, good afternoon. Thanks everyone for coming. Thanks, Brett, for allowing this to happen, and thanks the organizers for putting this together and inviting me to present my humble research, I would say. My name is Arturo Revilla. I'm a first-year PhD student here at the Architectural Association, and my research goes under the name of Processcity, Architecture and the Urban Border, under the supervision of Marina Laturi and Brett Steele. I will talk about this, but first I would like to give a first introduction of where I come from and how the research gets into a broader picture. In 2007, I graduated from DRL at the Architectural Association, together with my teammates Pablo Flores, Xiaowei Tong, and Feng Xu, and under the tuition of Tom Bervers. I started an urban investigation based on different computer fluid dynamics engines and their potential to coordinate alternative strategies of urban design. Time-based digital simulations were used to produce programmatic speculation, formal variation, and spatial innovation. The parameters embedded in this type of engines allow us to generate fairly flexible proposals based on local information. Very basic computing allow us to a degree to deform surfaces and generate massing scenarios. That's what basically happened. And eventually we came with this proposal. And this was 2007. After DRL, I graduated I worked at did Architects, where I had the opportunity to experience how innovative design tools and techniques are implemented in the phases of architectural design. Nevertheless, and beside the motivating results of these first stages, new questions have arrived that could only be addressed under the scrutiny of further research. So, during the past months of investigation, I have concentrated my efforts of establishing a critical position on the relation between contemporary architectural design and the city, with the aim of having a theoretical frame to evaluate the relation between design practices and urban development. The research uses the concept of flow to make a historical dissection and revisit the different moments in practice of design that have determined the way architects address urban dynamics today. Processcity is an attempt to close the gap between morphogenetic design processes, materialization, and social practices. The research uses Alfred North Whitehead's temporal character of reality that dominates his process philosophy to establish a critical position on the challenges that architecture and public space face in the phenomenon of the megacity. The idea is to experiment with the potential of networked practices, the dynamic of urban systems and social interaction, to expose the urban border as an interface for architecture to actively participate in the generation of alternative forms of public space. Using simple manufactured techniques, this thesis will generate different interventions that will try to expand the way we use public space and generate cities. So to give you a hint to where this research is kind of going, I'm going to present you guys a project that has been running parallel to my research, which is based on the recollection of 40,000 plastic bottles in an attempt to blur the way materiality and the generation and the process of materiality generates public space. So in a way, we're trying to blur the relation between architecture material practices, public space, and social circles. This is more or less the model. All this recollection and all this project has been basically done through Facebook, which was quite amazing. And at the beginning, it started like a very kind of with a lot of ingenuity. But when we received, like 2 weeks ago, a call from IBM to motorize this and to eventually produce it with Arduino and speculate around this problem, was very motivating. They got really interested in this project. They got really interested in the project, not so much because of the complexity of the computation, but because we managed to connect institutions, public intervention, manufacturing, recollection, material, and with a very simple set of rules that could eventually propagate and produce this thing, which at the end, in a way, has no author. So in a way, the whole question of the research is what can architecture do to produce a new way of intervention in the way we produce cities today. Thank you.
Axel, I would like to have you now.
All right, thank you very much for the invitation to join the symposium. And I'd like to speak about my take on the translating the intangible, which I think is very much tied to the question of design models. So we've heard already a lot about models. In the sense in architecture, it's often perceived as a representational entity that at a different scale, a different material, different level of abstraction, captures or represents ultimately an idea. But I think we need to really reframe that understanding, which of course is already the case in most disciplines, that models really are bigger entities that really embody conceptual ideas and also increasingly the computational aspects of it. And again, this isn't necessarily something new for architecture, but it's definitely new in terms of the limitations and challenges that it brings about. And the fact that using computational models ties oneself much more to the limitations of the chosen algorithm. It's much harder to break out of it, in a sense, extending it and sort of glossing over the differences that may emerge as one engages them. So in a sense, we're becoming increasingly dependent on the models, and the models become more complex, but at the same time, they're not always helping to actually expand and support the sort of fluid notion of a project. So ultimately, the translation of the intangible relies on models of design. And model as code, as I just tried to point out, is a key aspect of that. So it's empowering, but at the same time, it's also always an investment, and it's difficult to break out of an investment that's ongoing and relies on many years of research prior. And also, certain things are very easy achievable in a particular algorithmic mode, and other things are much harder because it requires the retooling and remodeling of the problem. So control is one part of that. So what are the choices of representation? We choose to actually implement the design. So in architecture, that is somewhat obvious geometry. So geometry has a long history, but the way we are engaging geometry today is really as a sort of mainly surface-based representational tool, not so much as a sort of much more fluid sort of thing that allows discovery to be happening in the visual process, because we have to go through the numeric embodiment of the descriptions in geometry. So there's potential in that if one shifts some of the authorship to algorithmic processes, like in this very simplistic averaging algorithm between a random vector field, that we see certain things in it, like forms are emerging, things that we may appreciate aesthetically are appearing. But this is just one part of the equation, of course, because if you want to capture whatever we see aesthetically emerging, it's completely different story to actually operate on the emerging principles as a phenomena rather than just pointing to it or freezing it and producing it. So this is at the very simplistic level of this little sketch, 5-minute sketch of a vector field. But what if we go into more complex problems, such as, for instance, was already said, like cities? So there's the notion of simulating. This is, again, a simplistic sketch of a traffic pattern, being curious what happens if certain right turn, left turn things are prioritized over others. Was a little sketch done in the concept car study at the MIT Media Lab in the Smart Cities group many years back. So this gives one a sort of top-down view of how little agents' behavior affect maybe the overall behaviors as traffic jams emerge, as the street pattern changes, etc. But there's other principles, such as, in this case, what if one really rethinks the entity of the car, let's say? So what if the sort of pristineness of the car as an untouchable body gets challenged, and you allow for crashes, you allow for rubbing up, like Joachim was throwing out there, like a herd of cattle, right? What's if you have group dynamics of traffic, which is much more like an animal crowd, right? Where you're basically challenging the foundations of how you model things by looking at the actual entity itself and how it's been carried over for many decades. So in this case, it was a sketch responding to that. What if you have soft articulated vehicles, in a sense, how would the traffic pattern and how would the surrounding city change with that? So once you shift some of the prime constraints, I guess, the whole aesthetic and the whole design parameters around it can shift quite radical. Not so much radical because of its radical nature, but because of its disruptive nature with respect to the precedents. Because you're not designing a sort of painted glossy metal shell anymore, but it's a very different thing that suddenly seems to be optimal in a sense. So social configurations are also important. So again, using this car study, some of the work I did there, to look at that. So the configuration of social entities in buildings are very large scale, but also in vehicles with this range from sort of 1 to, I don't know, 7, 8, depending on which country or culture you are, packaged in a sort of moving envelope, produces quite many drastically different configurations from the sort of usual 4-pack type square configuration that we see in most cars. So just looking at a simple combinatorial exercise like that, based on social drivers, not even looking at engineering, makes you realize how easy it is to break out of the conventions, right? But then, of course, a whole trail of other things follow. Steering wheel is another favorite element of mine. So being in the sort of concept car study was humbling in the sense that you make, of course, all the mistakes as a beginner in that realm, but at the same time, it's very easy to then do mistakes and be provocative, for instance, as in replacing the steering wheel with a sense of an exoskeleton that you wear that is decisively collaborative in the sense that you do not aim for a sort of unfailable contraption, but deal with, let's say, 20 degrees of freedom as expressing intention to a machine that then has to interpret, let's say, competing inputs of 2 drivers or 2 persons, which resembles much more dance or skiing or something like that, right? So again, the goal is not to fetishize any of the sort of formal aspects or car or driving. It's just a case study of looking at a design domain which is hugely populated around the stylistic principles, but very little is being done to actually sort of challenge the underlying principles. So I think this can be maybe helping in doing worse, let's say, with these types of exercises, but in understanding where the constraints are that need to be challenged in order to make actual advances. So this is then taking such ideas and engineering them to some degree, making functional prototypes, in this case, the 8 degrees of freedom vehicle that basically is a skeleton-like thing that can articulate itself, shift its center of gravity, basically sit down, so to say, when it's switched off, because it would otherwise fall over. So the notion of design exploration here is really the chaining of constraints together, leading to quite different design aesthetics and design problems, and also such as that with the sort of bone muscle structure of an articulated vehicle, which isn't optimal in any way or better than anything on the road, but it serves sort of as a mirror to question what is sort of almost taken for granted as engineering principles around mobility, which ultimately is the question here. So it's not these devices necessary, but mobility also, as was mentioned before, in the city, right? That's a much more complex organism of how to get around, right? So this was just some design explorations in that, and also trying to externalize the patterns and dependencies between them. Something which is an older study in material and fabrication dependencies, which was a fascination of mine to look at sort of more fluid interactions between material based on geometry as the embodied assembly principle. So it's been used similar principles in hundreds of ways now, so it's extremely mainstream, but this was done in 1999. So actually realizing the first time, so how these two things can come together, and code then basically embodies these constraints, and then expanding that to a more complex design study of a chair. And since it's about translating the intangible, so this is really for me the translation, right? In retrospect, looking at the different design drivers, like proportional system, material, curvature, connection, assembly, and fabrication choices, and really looking at how each choice has a sort of chain of consequential sort of decisions trailing it, and each of those, of course, constrains the possibilities of what you can do with that driver through basically propagating these constraints further. So that brings in all kinds of things like fabrication tolerances, and also the limitations of geometry, and of course the engines that implement that. Like, so in this case, it's one unit basically of this entity that basically has to negotiate all its neighboring constraints, but also its own snap-fit sort of spring-loaded assembly principle. And of course, a lot of the material properties, such as breakage at certain tolerances, are extremely hard to capture in a geometric-only principle. So it has to go through a numeric sort of adaptation or approximation through trial and error in fine-tuning it. So it's ultimately a failure of the parametric system to capture this, but you can get away, I guess, by making one or two, in this case, two instances, which were successful to assemble. But there's a lot of luck in that, and a lot of sort of untranslated experience, I guess, in dealing with the materials in trial and error. So I'm showing that mostly as a shortcoming of the so much heralded parametric systems. If you look at also the translation of all the dependencies, you see instead of a circular sort of push and pull where every driver has an equal say in the exploration, it becomes a very centralized sort of spider-like thing, where CATIA sits in the middle and is controlling everything, as opposed to a really fluid interaction where sort of disciplinary boundaries at larger scale projects would actually influence each other. So just some larger scale, so the deployed adaptable sketches. So this is another strand I'm interested in. What if the parameters actually are not constrained to one set in the design space, but actually map over to kinetic structures? So some sketches around like this kinetic bridge. So how could one do something that's sort of assembly and has a stable state at all cases, and at the same time exposes a certain, I guess, elegance or beauty in its deployment, which is going further to this study, which is a study of a curved crease origami structure simulated here in processing, which needs a single actuation, the 4 black bars there, single point actuation to actually pop itself into a arc-like shape, and then studying at the same time all the force distributions during that deployment to understand something about how the structure would work at full scale as a deployable lightweight bridge structure, which basically has a very simplistic assembly principle of a flat sheet just creased in the strategic places. And the last thing also about it, you can see the intangible aspect in terms of here, the traces, the actual history of the particle as they move through space, which is extremely difficult to predict analytically. So you actually have to really simulate it to understand how all the nodes travel through space in order to be able to to predict the next state of the system. So, and this is of course important for materialization and structural implications, and also stability, to basically design systems that also can adapt themselves during deployment. So if the load changes, it would basically take a different arc, a different position. So that's some ongoing research right now, which isn't finalized, but I wanted to show it as a sort of fitting the topic. Larger scale, imputation was a kinetic tower, articulated tower, using pneumatic festo muscles. So here the idea was, with Philip Locke and Peter Schmidt and John Snavely, to do an active structure, basically a tower that does not need to be built for the worst case scenario, but rather can take a posture and sort of lean into and reposition itself in order to respond in predictive manners to perceived oncoming loads such as wind gusts, etc. Which was interesting was that the building seemed very difficult, and we did it all in-house, but what was much more difficult ultimately was the problem of sensing and control. So I think from architecture, we've seen also several interactive projects already. I think one has to really understand that the actual control of complex systems is really where the big challenges are at, and also the interdependency between complex sort of physical systems and their sort of more intangible control entities that are really not about shape and form so much, but like in this case, an 8 degrees of freedom structure on the top. You see the movements of these dots representing basically the control inputs to the tower, and at the bottom you see a geometric predictive response of that. But of course, this doesn't take into account, in this case, simplistic geometric simulation, the latency of the mass as it's being accelerated and all the faultiness of the accelerator of the actuators. So steering this tower to just do what you wanted manually was already a huge challenge, and to make it a sort of robust, predictable structure that would basically act like noise-canceling headphones in a sense, by not moving but by actually canceling out movement, is really the hard problem. Just some more sketches on the notion of the intangible through design tools, so performative, geometric, and force-dependent form findings, where one can embody a lot of the knowledge and understanding of a domain, such as computational geometry and also structural behavior, to then generate sort of classical, I guess, compressive-only forces. So I've been working for some time on these sort of interactive tools that where you really model with the flow of forces in an active environment and become aware of them as a process of discovery more than one of optimization, which then allows you to respond to the emergent sort of design constructs in observing how every addition reshapes and restructures the forces as they are being deployed. So that is ultimately form finding or discovery of design, I guess, but what I'm more interested in ultimately is the steering of form, which is, to my notion, very crucial to get these type of tools towards not an optimization process, but one where you, as a designer, can deliberately take on compromises and suboptimal structures in order to steer the design towards an expression that you are interested in. So this was the first sketch of that, which is shown here. Which allows a catenary arc, which initially is just in its optimal, let's say, catenary form, to add rotational resistance to it in the red and the blue section, which now allows this sections to be moment resistant selectively. So you basically dial in the compromise of, I want this arc to be flatter here, but I have to buy that basically by adding moment resistance, meaning it turns into a bar here as opposed to just a compressive stacked structure. So basically as a first sort of simple sketch of the notion that I would like design tools to become much more like that, so that reflection of the value system of the designers who would also design the tool themselves in response to their goals, and really having it as a discovery steering process, right? Which of course gets much more complex as things, many more variables become involved. But that's, to me, ultimately the goal. So to explore form and steer form in presence of, for instance, structural or other constraints. So it's not arguing for a particular minimalist sort of structural aesthetic, but to employ such explorative systems to all kinds of other constraints. But that requires ultimately the discovery or the definition of new models of design in order for these things to become more fluid and also more all-encompassing of the things we care about. So this is just another small sketch using, let's say, a gliding anchoring type mesh on a surface, simulating the force distribution to discover sort of multinodal meshes and see the force distribution live, and also the panel state of it as a sort of predictive sketch of such structures, and also exploring the aesthetics and spatial potentials of it. So in closing, it's basically the use of computational design to embody design knowledge and constrain and relating them to design into an interactive system that allows for an exchange between model and design intent, and to change the role of drivers from input to analytical models to design, as opposed to confirm design intent, to that of being embodied in bidirectional models to help explore design intent in the presence of these constraints. And ultimately, it's the models of design as the embodiment of this design intent and intangible knowledge. Thank you very much.
Thank you, Alex, to share with us your experience, and then with following Branko Kolarevic.
I have it on the screen, so it should be. Yeah. It's a great pleasure to be back here. I was here in January for the MTech keynote, and I want to thank the students for inviting me to speak again. Back then I spoke about the architecture of change, and today I decided to kind of address a slightly different topic in response to the kind of our increasing capacity to deal with complexities in architecture. I was lucky that some of the speakers before me did address this subject of complexity. Hod Lipson spoke about complexity as being free. We have seen a range of tools in Axel's presentation that manage to model some rather complex phenomena. My concern here is that as we kind of translate the intangibles into tangibles, and as we try to then model these tangibles in some kind of complex ways, that we might be losing the sight of intangibles. It sounds a little convoluted, but I will again try to explain that a bit more as we move along. It's also a kind of a quest, personal quest, to kind of simplify my life as it's becoming more and more complex as I kind of age and as I get engaged in more and more stuff. So my talk is about complexity and simplicity, and they're ultimately related to simplicity and complexity, and you will see how that plays out later on. I thought I should address in a somewhat critical fashion the title of this session that implies that innovation in design is a function of nature, fabrication, and material. And I think while that is true, I think this kind of variable part of this function is much more complex. And one could actually factor quite a few things in trying to come up with things that are innovative in the context of architecture. So the subject of complexity in the context of architecture is a complex one. It encompasses quite a few realms, from social and cultural through programmatic, functional, formal, spatial, tectonic to performative and phenomenological. And what I'm going to do today in the kind of brief amount of time that I have is address the formal, spatial, and tectonic realms as they pertain to complexity. This is how things used to be, and they still are in quite a few places. We had a period in architecture in the 20th century where we had these rather simple forms with some rather simple programmatic agendas, with the kind of simple economic models. We have seen their kind of propagation in the cities, leading to this notion of visual, informal, monotonic simplicity. And then as the digital has entered the equation, we have acquired a capacity to deal with more complex conditions, not only in the kind of context not only in the cultural context and the social context, but also formally and tectonically. And I think this building by Frank Gehry was the kind of harbinger of things to come, where we have a present condition that I would call complicated complexity, which actually I see rather as a problem that needs to be addressed somehow, and which is what I want to address today. So as I said, the talk is about complexity and simplicity, and you can think of them as being on two opposite ends. And what interests me is this kind of in-between condition where we could contemplate concepts such as complicity and simplicity as kind of hybrids of the two. I did not invent these terms. They actually come from popular science. There was a significant title, a notable title that was published in mid-90s when these concepts emerged in popular science by Jack Cohen and Jan Stewart, who in the collapse of chaos, discovering simplicity in a complex world, wrote that complexity is essentially an interaction between co-evolving systems that support a tendency toward complexity, and then the opposite, simplexity, or similar to complexity, is simplicity is defined as simpler order to emerge from complexity. Then a few years ago, Jeffrey Kruger revisited this idea of simplexity, published a book in which he tries to explain why simple things become complex and how complex things can be made simple. He defines complexity as a complementary relationship between complexity and simplicity. And I would offer even more cogent definitions of the two. Simplexity as being simple complexity, and complexity being complex simplicity. There are some interesting examples from Jeffrey's book. He does mention iPhone as the ultimate example of complexity, something that is simple to use, but is actually incredibly complex in order to attain that simplicity in the end. I would illustrate this idea of complexity with a simple project by two friends of mine, two colleagues from Zurich, Fabio Gramazio and Matthias Koller, who designed this dining table with holes. It's a kind of interesting dining table that you would have to kind of navigate carefully. But that can be designed on the phone. So they wrote an app that can be downloaded. This was before iPhone. We can enter the parameters for the table, 3 parameters, height, width, and depth. You can specify where you want these holes to appear. You're essentially defining the topography of the underside of the table. Then you send a simple SMS message to a web server where you can actually then go and see that table. You can assign materials to it, design it, and kind of in a material, with the material precision, have the table manufactured, fabricated, where you have a milling machine milling that underside topography of the table, so that's how you attain the holes. And these are some of the tables that their customers designed using that phone app that I mentioned. So it's a simple thing, simple design, it's a table, but again, some rather complex things had to be embedded in the process, in the system, in order for these tables to be designed and produced. Then, in the 90s, we also had this fascination with surface complexity, and this is my homage to Greg Lynn, the speaker who will be speaking shortly in the next session, where he, through his early work at Columbia University in New York, brought this subject to the fore and has done quite a few projects where the surfaces were the subject of exploration. In this case, the surface becomes shredded so that light and air could come into the house. And you actually do not need to have a blob. You can have a twisted box and use the same strategy of striating the surface and again, flexing the various striated bits in order to, again, enable the envelope to function as it's supposed to do. There are ways of dealing with the surface, not only in the formal sense, but also materially, which is what Herzog de Meuron did in this project in Germany, where they embedded images in glass and concrete, literally blurring the distinctions between the two. It's not a small feat to, again, deal with two distinctly different materials and yet make them function as one whole. And what we have seen recently in the previous decade is a kind of fascination with complex complex patterns and quite a few projects. And I like this project by Tom Folders from San Francisco, where he was commissioned to actually dress up what was rather an ordinary and cheap box building. The point that I'm trying to make with some of the things that I've just shown you is that we are kind of seeing an increased interest in what one could term to be the visual complexity of the built environment. And that has its logics in how our visual cognitive apparatus operates. Ernst Gombrich, a theoretician of art, wrote in a seminal book that he published in mid-20th century that we are genetically, intrinsically predisposed to read patterns around us. And if the structure of the underlying patterns is easy to decode, our cognitive apparatus disconnects. In other words, the eye and the mind becomes disinterested, which is what happens with architecture of this kind. It takes a fraction of a second for our brain to see and recognize the patterns embedded in these forms and surfaces. It didn't have to be that way. The other argument that Gombrich makes is that if the patterns around us are too complex, the brain would also disconnect. It would try to read, it would try to find some underlying structure, and if it's not succeeding, it stops. And his argument was that as architects, as designers who deal with the visual dimension of our existence, we need to strike that middle ground where things are neither too simple nor too complex. And one can actually read Mies van der Rohe's Barcelona Pavilion as kind of occupying that middle ground rather successfully, where the geometry is actually in service of the materials and the kind of complex intrinsic patterns that the materials that he used in this building possess. So many of you, know this project through its pochette plan drawing and black and white images, where actually it's a kind of an explosion of color and, as I said, rich geometric patterns. 6 different kinds of stone, 3 kinds of tinted glass, which was all the rage at the time, a chrome column, etc., with a subdued geometry, plain geometry, simple geometry, in order to foreground this complex material composition. Another notorious figure from 20th century, who famously stripped ornament from his building in Mihalsplatz opposite the Imperial Palace. But note what he did in Piano Nobile. He used some richly patterned stone in order, again, to keep the eye of the beholder engaged as one looks at his building. So at some point in my life, I became interested in this kind of middle ground where things are neither too complex nor too simple. And with my students, I kind of set out to explore that in some of the projects. Much of that work was inspired by Bernard Cash, who in mid-90s engaged in these parametric explorations and fabrications of various wood panels, simple computational processes, straightforward fabrication, where again the idea was to produce a series of similar objects that are differentiated through parametric variation. He even had a website where one could go and design these panels. This is what HTML looked in mid-90s. It was kind of rudimentary at that time, simple. There are manufacturers that kind of provide that capacity on an economic basis today. Again, Greg Lynn's work, I think this is one of the best things, Greg, you did, the base for the embryological house. I love this project. It's simply a very careful choreography of tool paths for the CNC machine, and then kind of ingenious use of wood, where the intrinsic qualities of the wood come to the fore. And it's the layered nature of the wood that becomes the kind of primary patterning of the surfaces. And then the tool paths, that drive the kind of fabrication become the kind of secondary effect in the articulation of the surface. And I like to show this project by Carl Dauben from Michigan for a burrito place, a kind of no-budget project, where he simply used the round bit on the CNC machine to control the thickness of the line as it's inscribed in a kind of red-painted sheet of plywood. So you can have a very thin line that thickens as you go deeper into the material. You can go all the way through to give that screen or ceiling a certain degree of transparency or translucency. So with my students, I set out to explore, again, that realm of creating complexity through some rather simple means, simple strategies, where we had to use a certain economy of method. I didn't want them to make complicated stuff, because everybody can do complicated stuff, complicated complexity. The idea was to engage in kind of simple strategies that can produce some complex artifacts. So less effort, less machine time, less material, less waste were some of the kind of drivers for those explorations. This was one of the projects, a paneling system that is simply generated from a Maya animation, where isoparametric curves are simply extracted from a sequence of frames. These isoparametric curves then become directly toolpaths for the CNC machine, where one then simply has to choose whether it's a flat bit or round bit. And then at the end, these panels can be produced rather quickly. They could be acoustic panels, for example. 15 minutes of milling for a panel that is about 1.5 feet by 3 feet in size, and kind of a small amount of waste as these surfaces become articulated. A script that has 60 lines of code producing this kind of V-like effect that you see at the top. But then when you employ wood as a material, that kind of layered nature of the wood and the subtle patterns that begin to emerge, that becomes the primary motif and not necessarily the geometry that is then imposed on the material itself. This is one of my favorite projects that involves some incredibly complex piece of software, parametric software called Photoshop. That's what it was, right? So no Rhino, no digital project, and so on. So what the students did is they took frames from a video sequence, applied a video filter called, an image filter called motion blur to produce these kind of striated images that you see on the top. At the bottom is the halftone filter applied to the same sequence of images. The first ones were to be height maps that you can bring into Rhino and create a topographic surface. So the two were then brought into the material, and obviously things didn't work. So the halftone was gone, and that kind of simple striated images were brought in order to create a simple installation that you see here. This is another exploration, a kind of zero waste fabrication. The more I was involved in fabrication, the more I was astonished how much of the material we are wasting. So the thinking was there has to be a better way to fabricate complexity in the articulation of surfaces. So we looked at expansion of the material, where you simply make straight cuts, as you can see at the bottom, and then you subject the material to some kind of plastic deformation, either through heating and pulling or simply through pulling. So here you see a piece of acrylic that was cut with a simple pattern, as you can see at the bottom. That is then heated and then pulled apart. The students wanted to do this in aluminum, and their kind of idea of expansion was to tie this sheet of aluminum to 2 pickup trucks, rev up the engines, and pull them apart. And of course, I stopped that in the tracks because all I could imagine was some people being killed, blood being spilled over, and so on. But you see the idea that we can be rather clever about some of these complexity, deploy some rather simple means, and yet attain some rather complex looking effects and results. This is a sink designed by a student who used the CFD simulation of placing the cylinder in a simple flow. The emerging flow patterns were then analyzed, and these diagrams of the velocities, fluid velocities that you see on the right, were simply used as a topographic map in order to generate the geometry of the sink. This is a recent project of ours, a facade system that consists of rotating components. They're all the same, so truncated cones that are cut at an angle, but these cones rotate, powered by motors and so on, in order to create an incredibly dynamic looking facade. I'll conclude by showing you 2 projects by Andrew Cutlass. This one was in San Francisco, an incredibly compelling panel installation where each of these was produced by pouring plaster into an elastic mold. So no CNC machining, no parametric design, just a rubbery sheet that is pressed into some template with some dowels. You pour the plaster, and you end up with something that looks like this. We invited Andrew to our faculty in Calgary to do an installation and work with our students over an intense one-week period. This was the installation, a kind of a partition that is called Zero Waste. These are all the pieces fabricated with almost minimal waste. The only waste is the dust that results from the milling of the pieces and produces this incredibly rich kind of looking surface in the end. Very simple, very straightforward, but a kind of clever way of deploying geometry, fabrication, and material in the end. So, in this complex world that we now occupy, that is populated by Arduinos, grasshoppers, Galapagos, and so on, I would try to make a plea for what I call the kind of simple complexity or simplexities in short. Thank you.